Hello everyone, my name is Nathan and I'm the leader of the past BI virtual chapter and I'm going to be the host for this session and I want to welcome everyone who joined this webinar. And today Reza, he is from New Zealand and he is going to present about data preparation in Power BI. And I want to thank Reza for accepting my invitation and presenting this webinar. Before I hand over my hand over the screen to Reza, let me go through some of the past slides and then I'll hand over the session to Reza. And we have this past summit every year, and this year we have in Seattle on October 25th, and our virtual chapter has a chapter discount code, and if you use this chapter visual discount code VC15BRD5, you will get $150 off. And I encourage to attend the past summit, and it's a very useful summit, and you can gain a lot of knowledge about SQL Server. And PASS has a lot of virtual chapter, and like this business intelligence virtual chapter, there are other virtual chapter, and there are some chapters which, for different languages too. And you can go and register to sqlpass.org/vc to register the virtual chapters you are interested in. Here is a list of meetings happened this month, and some of them are already over, and like so, and here is ours which is happening today, and there are other webinars. It's for one is on 21st by DBA fundamentals group, and data architecture group is going to have one on June 22nd, so you can attend these webinars and then gain knowledge on those platforms. And I hope you all know about SQL Saturdays. There are each Saturday, like at least there will be one SQL Saturday happening somewhere in the world. And actually tomorrow there is one going to be in Miami, South Florida. And if you are from Miami, please go and attend the SQL Saturday. And there are a lot of good topics, and a few of my friends are going to be presenting there tomorrow. And like I'm a volunteer for SQL Pass, and you can be a volunteer. You can register to be a volunteer in the volunteer.sqlpass.org, and by volunteering for the hosting this webinar or helping the SQL Pass, the Pass leaders, and so that you can help each other. Here are the links for the SQL Pass websites, like the LinkedIn site, the Facebook site, Twitter, and the Pass. So now I am going to make Reza as the presenter, and then change the make him as a presenter. So there will be a few seconds lag, and then you should start seeing his screens, and I'm going to make him the presenter.
All right. Hello, everyone. Thank you for joining this session. Can you hear me, Nathan?
Yes, and
I started showing my screen, so it will come up in a few seconds, I believe.
Yeah, we can see your screen. I can see your. Yep.
Yeah. Okay. Welcome everyone to my session, and especially thank you, Nathan, for giving me the opportunity to present. So this session is about data preparation with Power BI. During the session, if you have any questions, you can type your questions in question box, and I will ask Nathan during the session that if there is any questions that you can answer or not. All right, a little bit about me. I'm Reza Rad, SQL Server MVP, and from New Zealand. It's right now Saturday, 10 a.m. in my time. I believe it's almost evening in most of audience time. I'm author of some SQL Server BI books, and I'm also the author of Power BI online book from Rocky to Rockstar, which is free. Everyone, you can search Power BI online book, and you will see actually my posts in that Power BI online book. And I'm leader of New Zealand BI group, and also Persian Persian virtual chapter, and these are my contact information. So if you have any questions, just flick me an email. I'll share these slides through Nathan later on with you. Okay, a little bit of agenda before going through that. This is a shrinked version of my session in past BA conference in San Jose, early May, which was a couple of hours. So this session is 1 hour, so we will skip some parts which I think would be familiar for you. We'll go in through parts that are most necessary for you to learn in terms of data preparation. I'll start with a bit of information that why we are doing data preparation, then I'll go through just an overview of Power Query, which I believe most of you are already familiar with that, so we'll go through that very quickly. Then I'll go through Power Query for Mule language, which is our tool for data preparation, especially with Power BI and Excel, and I'll talk about 5 functionalities in Power Query, which is especially for M and makes your data transformation much more powerful. I'll show you how to create a data dimension with Power Query, and if we got enough time, I'll show you a couple of use case scenarios, one for fit with data integration, another for online course date time scheduler. All of demos and the stuff that I'm showing to you today will be available online on my blog, which is in Radicat website. So if I hadn't chance to show that to you today, you can just go through my weblog and see those information. All links are available at the end of this presentation. Okay, let's get started. So steps to data insight. Usually when you want to turn your data to insight or turn the data to useful information to make decision by, usually you first do data preparation. You prepare your data, and then you model the data and you visualize after that. So the first step usually is data preparation. That's your building blocks, that's your keystone. That's very important that you get your data preparation good and right first in advance. That will reduce lots of amounts of work that you might require to do as the rework because of that data preparation, because of bad data preparation later on. If you do bad data preparation, you might need to do remodeling again, you might do clean your data again, go back to data preparation and do a lot of work. So be careful that do great data preparation in advance. And what data preparation means actually? Data preparation means that you get data from multiple sources. You might have only one, but usually you require multiple data sources, you do data cleansing, you apply some data transformation, and you make your model ready for, you make your data ready for modeling. That's quite important because the modeling side of Power BI or any BI application is quite important to be right. So you can build a data model like this, which has many tables, and I've seen that quite a lot of people just open Power BI and connect to a database and bring all tables that they need into Power BI, and Power BI will automatically detect relationships, and they will end up with something like this in their modeling, which is fine. It's easy to build, but it's not performing the best. It's not good from different points of view. It's not good for user, it's not good for performance point of view. So if I compare that model with a model like this, which is much easier, I have all my numeric columns in one table in the middle, which we call in data warehousing terminologies, and all descriptive information in tables around, which called as dimensions. And only one link from one join from flag table to each dimension. I don't need to go through a dimension to reach another dimension. That's much better designing. Usually you probably heard about this kind of designing in data warehousing, and you might think, okay, that's for data warehousing where I built my data warehouse as a star schema. This is a star schema, so why I need to do that in Power BI or Excel, Power Pivot, or those kind of things. The fact is that these are all doing the same thing. So if I bring data, heaps of tables like this will reduce the performance quite a lot. User will be confused with number of tables there. Even if I hide a few, still I have quite a lot to show. This second one is much simpler, performing much faster. So this star schema is not only for data warehouse, this is for your Power BI model as well. And your tool for doing these kind of things, especially Power BI and Excel, is Power Query, which we will go through that. So I'll just go through a few do nots in this kind of data preparation. So what you should not, do not, is that you should not add all tables and files as is. You can bring them into the Power Query, do combination and data transformation and build much easier things, but you do not load them as is. And you don't leave naming as is, because I've seen quite a lot of namings like dim underscore product, like namings for columns like product underscore named, things that doesn't actually make that much sense for a user point of view. When you design your data warehouse or your BI model, you should design that as user will see that. So that's kind of your table in the restaurant, like what Kimball says in his Kimball courses. When you design your model, you should think about designing the table. ETL and data transformation is backside. It's in kitchen. That's not important what you are doing in kitchen, but what you bring in the table is very important. And you do not leave data types as is. It's quite important that you get them fixed right in advance, and you usually don't require to load the whole data set. I've seen many people that bringing a table with million records, then in all of their Power BI pages, they only filter, they actually filter all product categories that are not this, and that. And this is a filter applied in all pages. So if I have a filter applied in all pages, why I'm bringing that data first in advance? It's better to apply that filtering in the Power Query or in my data transformation steps. I've already explained why we are not doing that. So why we are not bringing all tables as is, because joining them together will cause a better modeling. Why we don't leave names of tables and columns as is, because user will have better experience, and also in my Power Q&A I will have much better result answering my questions in Power Q&A, and proper data types makes it much easier to model, makes it much easier in visualization side of things, and filtering will also make performance much better. So consider doing this. Create flattened structure, especially for descriptive informations, those that are related to each other, like product category, product subcategory, product. These all can be combined into one data set, one query like product, and name tables and columns exactly as you are designing this model to be served to your user. Think about your user when you are modeling that. Specify proper data types for each data field. It's very important, because then in your data visualization it will be much easier to use them, and remove outliers, like if you have nulls and blanks and very big values, some data quality issues that you know that it's a data quality issue and it's an outlier and it doesn't make sense to bring that in the model. If you want to show that outlier somewhere in your model as an insight, that's absolutely fine. But if outlier is just an outlier, everyone knows about that, so just remove that. And filter part of the data that is not required. All right, so that was kind of a concepts of data preparation, some things that you would need to consider. Now, what is our data preparation tool in Power BI or Excel? That's Power Query. Power Query actually named as get data or get data and transform in Power BI, so you might have heard its name like that. Let's go through Power Query introduction. I'll do that very quickly. So what Power Query does, with Power Query we can connect to many data sources, Excel, Hadoop, Azure data sources, SQL Server on-premises, CSV files, and many actually data sources. I can combine those data sources, I can do some data transformation, like concatenation, like grouping, like pivoting, unpivoting, all those kind of things. And I can load my result set into Power Pivot model or into a Power BI model itself or into an Excel sheet. So that's what Power Query does. Power Query comes in different shapes and sizes. Power Query is part of the Power BI. You've probably seen that in Get Data part of Power BI. Power Query also comes in Excel 2016 built-in. That's in Data tab in your query that you will see Power Query options, and in Excel 2010 and 2013 that's a separate add-in that you have to install, and when you install that you will have a tab in your Excel called Power Query. Right, so how to get it? If you download Power BI Desktop, which is free, you will have Power Query. If you have Excel 2016, you will have Power Query embedded. But if you have 2010 and 2013 Excel version, then you just download the free add-in for Excel. So it's mostly free for you to use, and as I said, wide range of data sources are supported: XML, CSV files, JSON, even softwares as a services like Salesforce, like Dynamics CRM, these data sources, and sometimes you can get data from web. And all database vendors also supported. Data transformations in Power Query are very easy to apply. Usually you just use graphical user interface like this. If you want to trim a value, if you want to concatenate, replace values with something different, which is really easy to apply. And then you can choose where you want to load your model in the end results. Usually by default, Power Query in Excel load the data into an Excel sheet. If you are using Power Query in Excel, always remember that change that option from table to only create connections, especially when you do not want to show that directly in the result set, because if I choose table, then for every query that I have in my Power Query, I will have a sheet in Excel which is killing and makes my Excel file big. And then I can choose load to data model, and this will load that into Power Pivot. If I'm using Power Query or get data and transform in Power BI, then I don't need to do this step because that's automatically loading that into my Power BI model. Right, let's go through a sample of Power Query. So for this sample, I'll be using a website here which shows some information about movies sales, gross sales, their domestic sales and international sales. That's box office mojo that shows these are movies and their sales in millions a year. For example, I can see Avatar, Titanic, Star Wars. These are movies that sold the best. And I have a list of top 100, then from 101 to 200, all those movies listed here. Right. So the good thing about Power BI is that I can use this web link as a source and connect it to this data source and build actually a visualization on top of that. So I'll open my Power BI desktop, which is, as I mentioned, free for you to use, and load that Excel into my Power BI. So in Power BI, I can go to the Get Data and Web. I choose Web. That allows me to paste the URL here, and when I press OK, this will search all tables in that URL and generate a preview of that table for me that I can use in loading data there. So I'll click on this. The first table is just probably a header table in my HTML document. The second table looks like this is the table that I want. I have titles of movies, rank, studio, all those kind of stuff. So I'll click on this. This is my preview, data preview type of view in Power Query, and then I'll edit. When I'll press edit, the window that opened here is actually my Power Query editor. So everything that I do in Power Query, all data transformations have to be done here. So here I'll build whatever I want in terms of the data set, and then I'll propose that as a data set to my Power BI model. So first thing is that I have this table here. This is preview of data, and I can name this query as something in the query setting option here in the right hand side. So I named this as top sales 100, and I have movies, titles, and you can see the type of actually data type of each column also mentioned here. So the rank is numeric, title is string. All of these are looking fine. Year, I do have a special character here, which is that extra character, so I'll like to remove that. I'll right click on this and say replace values, and I say replace this special character with nothing, and I can see that that is already removed. And I can also change the data type, because data type is string. If I click on that, I can say that this is whole number, and that's my year value. I can also rename the column to be year. And remember that what I've said about naming columns, these are quite important. For example, a name like this, overseas percentage, slash percentage, this is not a name that is actually useful for my end users. So I right click on this and say rename, and this is not percentage actually, this is overseas sales, which I'll just rename it to overseas, and this is sales in $1 million. So what I, let's say, would like to show in my data insight and report is in dollars. So I can simply click on this and go to the transform tab, and here in standard section I can multiply that by 1 million. So that means this column will be transformed to a new column, which its value will be this number multiplied by 1 million. And I will see the result immediately here. And all of the steps that I'm doing are visible here. So from the first step that I had here that extra character, I replaced that extra character, I renamed the column name, all those kind of things are available here. So if I want to go back to a step or remove an extra step, all those kind of things I'm capable of doing so. As I mentioned, we can apply some other data transformations here. For example, this is a percentage column, but it shows to me that this is a string column. I like to change it to decimal number, but if I change it to decimal number, what I'll get is an error. The reason for error is that this has an extra character, which is the percentage. So if I right click on this and replace that percentage first in advance with an empty string, and now I don't have any extra character. If I change it to decimal number now, this is the way to change it to decimal number. So it's really easy to apply these data transformations like this. Sorry, I mean to rename this column. So I'll rename this column also to overseas percentage or something like that. So that was for overseas. I'll have to apply these in domestic columns, worldwide, all those type of columns. Let's say I'll apply those. I'll show you how to apply that on, but this is only for top 100 sales. So if I want to bring top 200 sales, say from 101 to 200, if I click on that link, you see that that's same actually URL. The only thing which is different here is page number, which is page number 2. So I can do same process here, copying this, creating a new query in my Power BI and do all the steps again. Or I can do a small trick here, like right-click on this and saying duplicate. Duplicate will generate a new query for me, an exact copy of the first query for me with all number of steps like that. And what I'll do is that only in the source step, instead of using page number 1, I'll choose page number 2. And the result set, the end result set would be from 101 to 200. So that would be my top 200. There are much better ways of doing that. I'm just showing the most simple way of doing that. So I have top 100 here, top 200 there, and then I can combine these together. So what I can do is that it's always best practice to put these queries in folders because it makes it much easier to track them, to work with them. So I'll move these to a group. I'll call that the new group, and I call that as data sources. So I'll have top 100 in data sources. I'll bring top 200 in data sources as well. So I'll have these two. I right-click on one of these and say create a reference of that. So this would be exact copy of my top 100 sales. A reference is different from duplicate. Reference will consider the first query as the main query and we'll just have one step which is equal to what we had in the first query. Duplicate is exactly duplicate of the first query with all steps there as well. So reference is much better. If I change the first table, I'll have that in my all steps after that as well. So I'll rename this new steps to just top sales. So that's my top sales, and what I can do is this is not a data source, so I'll move that to a new group, and I'll call this group as I don't know, final queries. So I'll have my final queries here, which is getting data from that top 100 sales. This should also bring top 200 sales as well. So when I have this, I'll say append queries. Appends is like attaching these two queries like union. So I say top 200, and the result set would be one single dataset or table that has actually all ranks from 1 to 200. Okay, so that would be my 200 ranked tables. What else I can do here? You probably heard about IMDb, which has a list of top 250 movies. So I can bring this information into my Power BI and then work on checking these movies that are ranked best by users of IMDb website. Are there amongst movies that sold best or not? And as you see, this is also a web URL, so I can come to my Power Query and get data again from web. from IMDb website this time. And this takes a bit of time, depends on your internet connection, depends on the response time of the website and the size of the data to work with. As you see, this is taking a bit time, more than I anticipated. Oh, yeah, here it is. So the first table is not what I'm looking for. The second is. So I'll click on that and bring that here. And this would be my IMDb rating table, which I'll move to data source. Right. And for this rating, what I can do is that I don't need this column. That's an empty column. Also these two columns, I don't need these two. And I have IMDb rating and rank and title. Rank and title are all combined in one column, the rank, title, year. So I can just split this column simply. Rank and title is split by a single dot, like one dot, Shawshank Redemption. I right click and say split column by delimiter, and my delimiter is not listed here, so I say custom delimiter, which is single dot, and that's happened at leftmost delimiter because there might be another dot somewhere in the title itself. I'm only interested in the leftmost delimiter here. That will generate the rank for me, and I rename this to be rank. And the rank and title here, those are separated, this column, which is the title and year, those are separated with the year inside the bracket. So I can split this time by delimiter, which is open bracket. So my delimiter this time is open bracket, and that usually happens at the rightmost delimiter, as you can see here. That will leave a column for me with an extra close bracket, which I can replace that with an empty string to get rid of that. Now I do have my year, and I change the data type of that to whole number and rename the column to year. So that would be my year, and this would be my title. The thing is that this title has some extra spaces on it, so I'll right click on this and say transform trim, which will remove extra spaces from beginning and from the end of each string. So then I'll have proper naming, and I rename this column to be title, right? So this would be actually my column, my data set here, which is what I'm quite happy with that. I don't need to load the first two data tables here, so I'll right click on those and remove enable load from them because I don't want to load them into my Power BI. What I want to load is only these two, right? And I can now close and apply and create a relationship in Power BI or in Excel if I do have Excel. It's the Power Query in Excel is slightly different. I'll show you how that is different in another demo, but most of the functionality are the same. So I'll have these two tables here right now in my Power BI model. These are related to each other by a wrong field, which is rank, which is not the field that it should be joined with. It should be joined based on the title. So I'll just choose the title, and then I can build my visualization because it takes time to create that visualization. I'll just show you a sample of visualization that I've built previously with this data set. So with actually having these data transformation, I built a very simple model that can gives me some information, and I can build some visualization that shows me how is the gross sales of movies compared with the rating in the actually in IMDb user rating website. So here you can see that I have top rated and top sales, and these are movies that top sold, like Avatar, and movies that are top rated, like if I click on Godfather, which is the best top rated movie in IMDb website, I don't see that in top sales. If I choose a movie, something like Lord of the Rings, I see that somewhere here, and here I can also filter based on studio, and I see that, for example, for Warner Brothers, this studio built some movies that are also amongst the best sellers, like Harry Potter, Dark Knight, and they are also among the top rated movies as well. Kind of a very simple visualization on that. You can find all information about how to visualize this in my website. So that was a very quick intro to Power Query, and I'll go through Power Query formula language now. Oh, sorry, not this slide. Power Query formula language. Yep, this slide. So everything that we do in Power BI in the data transformation side is working with a formula language called M. M actually is informal name of this Power Query formula language. It is called as Power Query functional language or Power Query formula language, mostly called Power Query formula language, but it's a very long name to remember, so I'll call it always M. And it was named like M because it was M for mashup. So Power Query M scripts is much more powerful than the graphical user interface. So you've seen that in graphical user interface I can do some data transformation easily without writing any code. The thing is that there are many other options in Power Query scripting that are not available in the graphical user interface. So if you want to be an expert in Power BI, you have to be an expert in this scripting because that's your way of data transformation. And M structure is quite simple. You can see here that I'll have functions and functions return results. So as an example, this is a very basic syntax of M. It starts with a let expression. In that let expression, I'll define my variables. Like X is a variable here. It's untyped, and it takes its type when it assigned first with a value. So when I assign 1 to this means X would be a whole number value. And then I'll show the result set in the in section. So when I say in X, that means X is the output of my query. So a script like this, let source is equal to hello world, that means I'll have a variable called source, and that's equal to hello world. And when I say in source, that means I want to show that as a result set here. So and the result is showing that this is hello world. So very simple, and it's case sensitive, so it's quite important that you remember that lowercase x is different than uppercase x. That might be annoying at some stages. And when you work with Power Query or M, it's quite important that you know that there are 3 base structures, base data structures in M. One is table, which is actually a number of columns and rows attached to each other. Another is list. List is a singular column but with multiple rows, and record is single row with multiple columns. The way that Power Query illustrates and shows a record is somehow looks like list if you see these two together, but it is just a way of showing that in Power Query because it might have many columns and the scrolling to the right might be much bigger. So just it is the way of Power Query showing that the underlying data structure means that you have one record and these would be columns for that record. Okay, top 5 functionalities. When you work with Power Query and scripting especially, there are top 5 functionality that will help you to build data transformation as you would like. The first one is that there are bunch of built-in functions that you can use them. You have to only be aware of how to use them, how to search them, how to find them, and you can create your own custom functions, which is really useful for code reusability. You can do error handling, and you can use each singleton function and generators functions to build a loop structure type of things. So let's go through built-in functions. So there are heaps of functions for tables, like table.add column, remove column, select column, sort, all those kind of things, and functions, date functions, like year, month, all those kind of functions. And there is a specific keyword which I would like to show you here, which is called shared keyword. So what shared keyword does, doesn't matter if you are in Excel or if you are in let me close this, or you are in Power BI. In both cases, you can open a new file and go to your Power Query editor and to a scripting view of your editor and type in that shared. So here is my Power BI. I'll go to a blank query. Okay, blank query doesn't have anything.
Hello.
Everything that I have in my Power Query formula language here for me. So if I want, for example, to use any of these functions, let's say, for example, text.range, I don't know how this works. So I can click on this. This will show me documentation of text.range. It says that this returns text from offset based on number of characters count, and shows me some also example of that. And this window also allows me to call this immediately, actually, and work with this function immediately. So that's really helpful. And this is also in my Power Query. That's the beauty of the things. This is inside my Power Query window that I have the first query, which is this, and the navigation of that. So that's is very interesting, because now when I have this in my Power Query, I can turn this result set into a table. Once I've made that into a table, I can search for something here. So if I'm not that much familiar with Power Query tables, Power Query functions, I'm looking for something with time zone. So the best thing is that, okay, I come here and I say, okay, time zone, but we've got these functions. These are all my time zone functions. So I can click on any of these, and this will show me some information what it does. So for example, this function, what it does, this will show me that this is a switch zone function that switch one time zone to another time zone. These kind of things are really helpful when you work with Power Query, because someone like myself, I would never remember actually Power Query function. It's usually the best option for me to just use this to find the function. I think I've closed my PowerPoint presentation, so let's go back to the slides that I've been. Okay, the next thing is that Power Query can have custom functions, which is really useful. It helps me to create functions that reduce redundancy in my code and increase consistency. The way that functions are defined is really simple. It starts with an input parameter or a bunch of input parameter, and then function body, and then lambda expression. So lambda expression is like that. So I'll have my input parameter, which is x here, let's say, or x and y or whatever. So these would be my input parameters. Then I have these characters, which is equal sign and greater than sign, and then the body of my function. For example, x, the the body as function x plus 1. That means I'll add 1 to every x value that I have. And x definitely has to be integer or numeric in this type of function to work properly, or this second one would do x plus y. And I'll call that the whole thing as a function called add, and then I'll just call that function add with a parameter, and I'll have the results. So it's very easy to use. Parameters can be optional, and this is really helpful because then I can choose what to do if, for example, x is not available. For example, if x is available, then return x. If it is not available, then return nothing, or something like that, and I can call that as optional. And parameters can be, functions can be multi-line inside a let and in section. So I'll show you how that works. It's just very easy to work with. I'll just skip this. And generators. So Power Query doesn't have actually a loop structure. Power Query is a scripting functional language which doesn't have loop structure, which can be quite annoying because we need loop structure at some stage. The good thing about Power Query is that it has generators. Generators will generate a list based on structure. Let's say, for example, list.dates will generate a list from date, the first date that we defined, to the end date based on a duration. And I can generate a list from that. Or list.numbers will generate a number of, actually a list of numbers from the first number to the end number based on whatever I want to show. For example, if I close this, or let's say if I delete this and create a blank query, in Advanced Editor I say this is list of numbers from 1 to 10, and show that in the result set. That would be list of numbers from 1 to 10. And then I can turn it to table, apply some data transformation to it, and build something based on that. So that's how I use that as a generator to build a loop structure. And when I want to apply a function on each number of these, each item in this list, what I'll do, I'll use a function called each, a specific function called each, which is singleton function, and I'll apply something on each number of each actually member in that list. I'll go through a very quick demo because we are almost at the end of this presentation. I'll go through a very quick demo and you will see how it works. So for this very quick demo, what I'll like to do to show you is a sample of integrating some Fitbit data information. So let me remove this. I'll do that very quickly, and then we'll go through list of questions if there is any. So if you be familiar with Fitbit, what Fitbit is, it's kind of a smart tracker which track number of steps that you've done, your heart rate, your active minutes, all those kind of things. And this is actually showing how I've been doing in every day. If I go to yesterday, I can see how I did work in yesterday. I haven't synced for yesterday, I believe, but here are my steps, number of steps in each day. I can download this information in my setting. Oh, sorry, setting I meant. In my setting, and this will allow me to download some CSV files or Excel file. The thing is that I can only download up to 31 days of data, up to 1 month of data. So if I want the whole data set for a year, I have to download 12 files, which is fine. But how I can then integrate them into my Power BI. So these are some files that I downloaded from there. If I want to integrate those into Power BI, what I'll do is I'll bring one of these here. So I'll create a new data source from CSV, and my data source is here. So just one of these files, let's say for example this one. So as you can see, these identified my data in this field. So I'll bring that across. Okay, that's my data field. I can remove the first row. I don't need that. So I'll say remove top rows, top one row. And the second row is the row, actually this row is the row that I want to use as a header, column header. So that would be my column header rows, and then I have to apply some data transformation here. I have a blank row here, so I'll say remove rows, remove blank rows. I don't have any blank rows anymore. The date field here is string field. So I can go here and change that to a date field. But the best way of doing that usually is that this date might be different based on the date time formatting in my computer. Date time formatting in my computer is a bit different from that. So to be sure that this always works with proper date, I can do data conversion with right-clicking on this and say change type using locale, right? Locale means that I can choose which country date format I want to choose data from. So I want to change the data type to date with the locale of English New Zealand. You can see that there's everything here, English New Zealand, that's where I am. And when I change that, that's changed to proper date format. If you are from states, that's not proper date format for you. That's the proper date format for my own New Zealand formatting, which is day, month, year. But that's actually a proper date format. And for columns like colors burned, steps, these are numeric columns. So I change these types to whole number. Distance is by kilometer. I'll change that to decimal. And everything else, I'll change that to, sorry, everything else I'll change it to decimal. Let me select everything from floors, not to decimal, sorry, to whole number. So that's my data set. I'm pretty happy with that now. I have my active minutes, my fairly active minutes, all those kind of things, number of floors for every date. But the thing is that this is only for one CSV file. How I can make this for multiple files? I can use parameters here to create a parameter for file name and then define this as a function and use that function in another table, but I'll do that a bit differently. That works for both Excel and Power BI. So what I have here, I have a folder that have all these files. So I'll copy this folder URL, and one of options that I have in my Power Query is that I can get data from folder. So if I choose folder, and if I bring that folder here, so that folder actually brings all data sets here for me, which I can click on OK. And this is all data files here for me. And this is file name, extension, all those kind of things. In the content of file, I have the binary, which is exactly all things that I've had there. I'll want to do it a bit differently than going through the binary. I want to use functions and calling those functions from here. So I'll show that a bit differently. So what I have here is folder path. I have also name of file, so I can generate a full file path based on these two columns. So I'll go to add column, add a custom column, and say this is file path, and file path is equal to folder path, concatenated. This is concatenation character in Power Query. Double backslash, the reason for double is that backslash is reserved word, so I'll have to use this twice to skip that reserved word thing. And the file name. So that will be a new column, which is the exact file name. You will see that extra backslashes here, but this is just a view here. The main thing will work perfectly. I don't need other columns at all, so what I'll do is just removing all other columns. And I'll have one column which is file path. Now what I can do is that this is the thing that I'm using as a function. This is the thing that I'm applying on every path here. So what I'll do is I'll go to this one. Again, I'm saying that I'm not using manage parameters here to just make it in a way that you can work with that in Power Query for Excel as well, because the creating function there is a bit different. But with using scripts, that is my simple. So what I've done is that I went to that, and in Advanced Editor, that was the whole script to change. I'll just copy that, and then went to my source file script here. Before any steps here, I'll just copy that here, and I name this as process file function. So that's my process file function, which get an X parameter, and as the result, it will actually process that X with something, right? So I renamed that there, and I'll put a comma here at the end of that. So I just created that function. I haven't done anything with that function yet. I just created that function. I didn't call. So the result set would be exactly similar here. I removed the first query because I don't need that anymore. What I do instead in this one is that I'll add a custom column, and in that custom column I say process file, and I pass the file path here. So process file is the function that I just created there, and I name this column as data. And that means this will apply that column, that function on every data row. So that's the table that I have in every data row, and that's exactly the table that I want this to be. So I'll just remove this one. I don't need this anymore, and expand the whole data set. So that's everything that I have from July, October, or November, everything. So that's all my data set all in one with using a function. I haven't repeated that steps for everything. It's just using that function. So that was an example of Fitbit data integration that I showed you. There are other examples like work time, date zone scheduler, which I'll skip to show, which I'll skip, and you can read that in my blog post. So these are references to study more. Demos of these webinars are in my blog post. There are a couple of good books for Power Query, M for Data Monkey by Kempels, and Power Query for Power BI and Excel with Chris Webb. Power Query is changing a lot. I'm writing, as I mentioned, the Power BI online book, so to keep the most up-to-date information, it's better to read online information. It's for free. You can go to my blog and read Power Query blog posts, and let me know if you have any questions. Right, that was almost what I wanted to speak. Is there any questions, Nathan?
I don't think so. I don't see any questions, and I really appreciate your time, and it was a very good presentation. I learned a lot, and thanks for your time. And I will post this. I recorded this webinar. I will post this recording in our YouTube channel in a couple of days. When I send my next email, I will send the link for that YouTube, so that the people who registered but did not attend can have this presentation. And I really appreciate your time, and thank you.
Thank you for the opportunity, and
And
thanks
then
everyone for joining.
and thanks everyone, and have a nice evening or rest of the day. Thank you.
Thank you. Cheers.